Just a minute ago when we were going over the test, we're going to be doing this kind of graphing stuff the rest of the year. So if you don't quite have it yet, it's okay. You still have more time to learn it, but sooner rather than later. All right, what's the parent function here? X squared, which looks like what? That's right, parabola. And that's what it's going to be all day today. Today we're dealing solely with those kinds of equations. Now, where does this parabola get shifted? Very good. Very, very good. Right one, up one. Now, what if it hadn't been written quite so nicely? What if they had foiled this out? Now, we're going to be showing foiling the rest of the day, but I'm going to go ahead and just... What if it had been written like that? Not quite. Not quite. But the point I'm getting at is, what if they hadn't had it factored like this? All of a sudden, you can't just tell where it's going to shift. So how are we going to tell where its breakpoint was? And by the way, this, what I've kept calling the breakpoint, is what we're going to today call the vertex. That is the vertex of our parabola. This is section 2.2, by the way. And if they give you a quadratic equation, which is nothing more than any function with a highest power of 2. If they give you a quadratic equation, and it's not something where you can just pull out the vertex, which this vertex would have been 1, 1, right shift of 1, up shift of 1, that's your vertex. But if you couldn't do that, you're going to use this formula. If they just give you a straight up quadratic equation, this is essentially all you need right here. Then negative b over 2a gives you the x coordinate of your vertex. Negative b over 2a is essentially the only thing on that page that you need. 2.2. Yes, sir. All right. Negative b over 2a. Let me show you how that would have worked on the last problem had you not been able to just shift it by hand. Negative b, now remember, just like the quadratic formula, a, b, c, they're just the numbers. Negative b would have been negative 2, all over 2a. What's my a value? What's my coefficient from the x squared? 1. Negative 2 is positive 2 over 2, which reduces to 1, which we already knew it was. X value was 1. Now, somebody asked a great question during the test review. I believe it was Catherine. The reminder question. If you have an x value and a function, how can you always get your y value? Plug it in. So what you're going to be doing today, when I ask you for a vertex, and you can't just pull it out like this one, you have to find the x value by negative b over 2a, and then plug it into the function for your y value. So that would have been 1 squared minus 2 times 1 plus 2. So that's 1 minus 2 is negative 1 plus 2 is positive 1, which is where that 1 came from. And that is the vertex of our parabola. Now, this whole thing right here, that is a quadratic equation. That is the, I guess you'd call that the formula for the vertex. Vertex formula. When I teach this next year, I'm actually going to change up the order a little bit, because this first slide, you don't even need that. Just by knowing how your graphs shift, you can eyeball which one of those matches. F, G, H, or J goes with number 1. Raise your hand if you think you know it. F, G, H, or J goes with number 1. James. Very good. It goes right 1, up 1. And there we are. Very good. And which one goes to number 3? Here. Very good. J. Left 1, down 1. I'm sorry, not left 1. Right 1, down 1. And there you are. Yes. Now, what about this? What if, instead of G being this, what if G had been negative x minus 1 squared minus 1? Now this one also has a vertex of 1, negative 1. Well, somebody raise your hand and tell me how you think this would differ from this. Yes, sir. That's right. The negative in front of it, if you remember this when we graphed all these things on the wall, would flip it over and it would now be aiming down. That's actually a concept called end behavior, which we'll talk more about later. But that will serve you well on this next slide. Because if you notice, H and J are the same except for there's no minus sign. Now, you can't just pull the shifts out of these. So you need to find the vertex. We're going to find the x-coordinate of the vertex, and then we'll move on to the y-coordinate if we can't figure it out by the x-coordinates. So, vertex x-coordinate, negative b over 2a. So, for f, negative b over 2a, that's negative 2 over positive 2, which is what? So, at x is negative 1, do either of these two functions have a vertex around any x value of negative 1? No. So f is not going to work for any of them. Yes, ma'am. Sure. Negative b over 2a. So the 2 came here, and the negative is in the formula. Now, whenever there's no coefficient, you assume it's a 1. So that's where that plugged in. 2a. So for g, negative b over 2a, so that's positive 2 over positive 2, which is positive 1. Do either of these have a vertex at x equals positive 1? Yes. So this one could possibly be number 7. So we'll leave that one untouched for now. Now, let me just get this stuff out of the way so we don't need it. I'm just going to get it out of the way so we don't stare at it. Okay. What's my b value on h? 0. If there is no value, it's 0. So that's 0 over 2a, which is 0. Do either of these have a vertex at x equals 0? We're just looking at x values, anywhere along that line. Yeah, number 5. This one could potentially be number 5. What about this one? What is its b value? 0. So again, it could also be number 5. Now, g is the only one that had a vertex, so we can go ahead and say this one is g of x. It's the only one that had a vertex at positive 1. For number 5, we need to find the y values for these two. So I'm going to plug 0 into the function to find the y value of my vertex. So that's 0 minus 1. So far, so good. It is 0, negative 1. Plugging it over here. Negative 0 minus 1. Dang. That one is also. So both of these could work right now. Well, which one is it, H or J? It is H. Why? That's right. It's positive, so it's going up. This one is negative, so it would have been going down. So this one is H. Now, I'm not going to require you to show all that later. You just have to match them. So if you could do that and just eyeball it, then more power to you. I'm not going to require you to show all that. Any questions about that slide? That's probably one of the more complicated slides of the day, believe it or not. No questions? All right. Find the coordinates of the vertex. Okay. Well, doing it the quick way, who can tell me the quick way to find, or what would the vertex be for number 9? It's the same as the ships. What? Positive 1. Positive 3, positive 1. Remember, it's the opposite of what's inside, exactly what's outside. Very good. And you could do number 11 the same way, but for the sake of practice and for the sake of showing you that it's going to be the same, I'm going to go ahead and FOIL out number 11, and we're going to do it the negative b over 2a way. So that's negative b, x squared plus x plus 1 plus 5 when you FOIL that. So that's negative 2x squared. That'll be 2x times negative 2 is 4. Very good. Minus 2 plus 5. Not that the c value comes into play at all anyway. Bless you. So, vertex time. Negative b over 2a. So that's positive 4 over negative 4, which is, now, you probably could have already told me that, because the left, it would be moving left, negative 1. Now, how do I find my y value? Plug it in. So that's negative 2 times negative 1 plus 1 squared plus 5. So that's negative 2 times 0 squared. So that's 0 plus 5, which is 5. Once again, you probably could have told me that already. I'm just showing you, you can do it both ways if it's already factored for you. If it's not already factored, like 13 and 15, you can either factor it yourself or just do it the negative b over 2a way. Oh, negative b. I FOILed all this. Yeah, then I just plugged it right into there. 13 and 15 are going to work exactly like that. Negative b over 2a, plug it in for your y value. Questions on that? Okay. The next slide. We have to find the vertex. This is actually where we're stopping today after this one, so bear with me. We have to find the vertex. We have to find the intercept, which I'll show you how to do in just a second. But we also have to find this axis of symmetry. Well, let me show you. The axis of symmetry is kind of a stupid concept because it's so simple. Once you have your vertex, the axis of symmetry is nothing more than a line around which your parabola is symmetrical. That line will always, with a capital A, always be x equals whatever the x value on your vertex was. Always. Wherever your vertex is happening, that's where it's breaking. That's why I always call it the break point. So, whenever it asks you for the axis of symmetry, it's just x equals the x value on your vertex. Isn't that right, Pierce? Isn't that right, Pierce? Yes, good answer. Okay. I understand. I used to be a sleeper myself. Okay. Let's look at one of the harder ones on here. 21. Why can't I just go ahead and take negative b over 2a of 21? Yeah, you have to get the y by itself, always. So I have to move that to the other side. Now some of you might already be saying, hey, you could just do that the whole shifting way. And you can. But for the sake of practice, I'm going to go ahead and FOIL this out. Well, I'll do it the long way over here. Yes, ma'am. It does. It does. Yeah, it doesn't hear you very well. Well, if you would ask your questions louder, Rachel, then it would hear you. Well, actually, it's funny you should say that. I just, like literally last Friday, that's not right, whatever, a speaker. But since it already hears my voice, I was thinking about like hanging the speaker in the middle of the room, and you'd be amazed how sensitive this little guy is. And you can hear anything in the room if people speak up. So I can hear your little personal conversations. But I could also hear your questions. So that's very helpful. I was practicing with it on Friday. It's actually really, really good and sensitive. So I might do that so we can hear you guys better. I'm recording right now. I recorded first block, but it didn't go very smoothly. So. Nothing. It just didn't go very smoothly. Okay. What happened? It was horrible. A gorilla broke into the room and ate 4 students. What happened? What would have happened? Math happened, and people were bored. Okay. Negative b over 2a. 6 over 2. So my x value is 3 for my vertex. Before I go any further, who can tell me what my axis of symmetry is? X equals 3. It'll always be x equals that number. That is our axis of symmetry. Means if you were to graph that line, it would be the perfect symmetry line for our parabola whenever we're done. Okay. So how do I find my y value? Yay, plug it in. You should get so sick of saying that because that's the answer to most questions in this class. Well, yeah. Pierce, next time I ask you a math question and you doze off, just when you wake up, say plug it in. You'll have a 50-50 chance. Okay. That's true, depending on what the question was. So, negative 9 plus 10 makes us a positive 1. So here's our vertex. Here's our axis of symmetry. Only thing we have left are our intercepts. Where is it going to cross the x-axis? Who can tell me how they think we're going to find those? Give you a hint. We're dealing with quadratic equations. So, quadratic formula. That's right. The quadratic formula finds the intercepts for a quadratic equation. That's what it does. And its formula, negative b plus or minus b squared, I don't know this one, all over 2a. There's the formula for the intercepts of a quadratic equation. So here we go. Here's the formula I'm looking at. Negative b plus or minus b squared. Now please notice, this negative b does not mean the number is always negative. It means like negative 6. Or essentially it'll mean always the opposite of whatever that sign already is. Okay, minus 4ac all over 2a. I need more room. So that's 6 plus or minus 36 minus 40 over 2. Now some of your little alarms are probably going off in your head. Because they're saying, oh no, that's a negative number. And you're right. That is going to give us an imaginary answer. We just did these yesterday, so I'm going to just cut to the chase. Which reduces to 3 plus or minus I. Now, normally when you do these, I'm going to go ahead and say 85 to 90% of the time, you're just going to get something like 3 plus or minus 2 all over 3 or something. Some kind of fraction or decimal or maybe a nice whole number. But those are just your intercepts. Like let's say for a second our answer was 3 plus or minus 1. 3 plus 1 is 4. 3 minus 1 is 2. So on your graph, at x equals 4 and x equals 2, those are your intercepts. And you'll just graph them. And I'll show you an example of that in a second. This does not mean you did it wrong. It means that the roots, the intercepts, are imaginary. Who can raise your hand and tell me what do you think I mean when I say the intercepts are imaginary? Yes, sir. That's right. That's right. It's going to look something like this. Let me, I'm out of space again, dang it. Getting a little fuzz off. Here's what that would look like. Here's a random axis. What was our vertex on this one? 3, 1. Thank you. You guys must do a good job writing things down. 3, 1. It is an upward parabola, and it never touches our x-axis. That's what your imaginary roots are telling you. It never actually intercepts the x-axis, hence it being imaginary. for all of these, anytime you're trying to find the roots or the intercepts, which is what it asks for in the directions. Yeah. There are three ways it might ask you. Today it's going to say intercept. It might also ask you for the roots of the function, which is nothing more than x-intercept. It might ask you for the zeros of the function, which is also the x-intercept. 3 words that all mean the same thing. Now, if you are a perfectionist with your graphing, notice I just plotted my vertex and went upwards, and I was happy with life. If you are a perfectionist, no worries. You may be saying, well, how do I get it more accurate? From the first day to the last day, what is the easiest, most accurate way to graph? XY chart. So you'd be 3, 2, 4, 1, and 5. Plot your points, connect the dots, and you have a more perfect graph. I, however, am not a perfectionist. Since it said sketch, I sketched. Actually, it may have said graph, but I sketched, and that's all it matters. I met all the requirements it asked. Questions about any step we took in this problem? Yes, ma'am. You didn't graph it. You can't graph it. 3 plus I is completely imaginary. It doesn't show up anywhere. You have to picture your vertex has to be accurate, and it has to be going this, like if it's positive, it needs to go up. If it's negative, it needs to go down. Other than that, no. If you don't have intercepts. Most of them, let me give you an example real quick. Most of them will have like a vertex of, I don't know, -4, -3. It'll have intercepts, like when you solve this, it'll actually give you a number like -2 and -7. And then it's just a connect the dots game, assuming you can do that. And there's your graph. But yeah, the ones with imaginary roots, I just want to see it for the intercepts, yes. Yeah. Questions? Let's look at one more. One of a different form, and that hopefully will actually have intercepts. What? Too far. How about 35? No, 37. Let's look at 37. I really hope that thing has. Dang it, it's not going to. We're not going to look at 37 because that's another no intercept problem. 35. So before we go, look, we're looking for the vertex, intercepts, axis of symmetry, and then graph. Kyler, how am I going to find my vertex? Dang it, I was setting you. Dang it, you beat me to my joke. Justice, how do I find my vertex? -b over 2a, which is what? -1, very good. Pierce, how do I find my y value? 50-50. Plug it in. All right. So, for my y value, plug it in. So that's +2, -4, -3. I think that's -5. My math is correct. 2 minus 4 minus 3. What is my axis of symmetry, y'all? Jesse, what's my axis of symmetry? X equals -1. Very good. Time for my intercepts. Quadratic, -b. Plus or minus. B squared minus 4. C. All over 2a. Yeah. I don't know why they did Pop Goes the Weasel. What can they do with a better song? Like Imagine by John Lennon. Imagine? No, I wouldn't try. Okay. -4 plus or minus 16 minus -24. What is 16 minus -24? Thank you. All over 4. How does that reduce? -4. What perfect square goes into 40? That's right. Which will make that 2 radical 10. Darn it! Our second straight ugly answer. It's going to be at least real numbers, but I was really hoping we'd get just nice whole numbers. But apparently that's not what's going to happen today. -4 plus or minus, well, no point in rewriting it. You can reduce. Divide everything by 2. Now, no, that's right. Please notice, this is 2 answers. This is -2 plus radical 10 over 2. And this is -2 minus radical 10 over 2. Somebody please punch those in the calculator and give those to me as decimals so I can graph them. Make sure you put your whole numerator in parentheses if you're going to put it in there all at once. I guess I could just do it. I have a calculator up here. Okay. And the minus? Sounds good. Let's graph this thing. Yes, ma'am. Nope. Not really. Unless there's a perfect square factor that goes into it, you're not going to be able to. And that only has 2 and 5. Up here? No. No. Now, one thing the book likes to do is alright, quick little aside, people. One thing the book likes to do is I'm going to kind of bubble this off so people don't think it's part of the problem. If you get something like that, where one piece nicely reduces and the other one doesn't, the book really likes to break up their fractions. That way you get one piece that reduces and one piece that doesn't. I don't like to do that. But yes, you could do that by splitting it up if you wanted to. Yeah, that would be -1 plus radical 10 over 4. The radical 10 still wouldn't do anything. Alright, so we're ready to graph. Throw me some axes up, y'all. What is my vertex? Thank you. -1, 2. Wait, was it? -1, -5. I was like, if we're going upward, that's going to be imaginary. Okay, here we go. And my intercepts were 0.58, which I'm just going to eyeball to be about right, y'all. And -2.58, which, ish. Connect the dots. If you're a perfectionist, you can find some more coordinates with an XY chart, but I am not. And there you go. Finish. Questions? Yes, these problems can be potentially a little lengthy. Yes, you probably will have some homework to take home tonight. Yes and no about the fact that I feel bad about that. Yes and no. Any questions? All right. Let me amend this assignment since we've cut it in half. There we go.